Get a 7-2 from last time. I have a couple copies left. The last time we just went over 7-1. Did you guys have 7-2 from last time? Or do you need a copy? Okay. So last time we didn't start 7-2, we just did the Alex 7-1. We answered those questions from that. So we have 3 weeks of the semester left, and we only have 2 sections left to cover, 7-2 and 7-3. So we'll lecture for 7-2 today and tomorrow. I want to do kind of like what I did with 7-1, go over the lecture. In the lecture note, there's quite a few that I want you guys to kind of try as we go through them. And then we get through the lecture on Wednesday, I'll pull up Alex and go over those Alex problems for you guys. The text is a week from Friday, yeah. And then I'll introduce 7-3, which is very similar to 7-1 and 7-2. It's just a different type of shape. It's a parabola. So instead of a hyperbola, we'll have a parabola. So the parabola will just open in one direction, or the hyperbola opens in 2 directions, either up and down or left or right. And then we had that ellipse from 7-1. And all those formulas kind of look the same. So after 7-3, we'll spend some time just saying, okay, here's a formula. Is it an ellipse, is it a parabola, or is it a hyperbola? And then we'll say, okay, if it's an ellipse, we need a center, we need a major axis and a minor axis, we need endpoints and focus points. If it's a hyperbola, we'll need a center, we'll need vertices, and we'll need the axis of, not symmetry, sorry. What are we talking about? Asymptotes, the equation of the asymptotes. And then if it's a parabola, we'll have a center, a vertex, and a dextrous. So you might not know what the function is. That might be part of it to classify it. Do you need a 7-2? I gave it out last time. You have it, it's all right. So we'll take 2 days for 7-3, and then we'll review. Probably at the end of day 2 of 7-3, we'll spend some time, and I'll just throw up an equation. And I might throw up 5 or 6 equations and 5 or 6 graphs, and you have to match them. So you won't have to do it all for you. You'll be able to say, okay, this has to be an eclipse, and the major axis has to be the x-axis, so that would graph with this, match with this graph, things like that. And the review, so I'll probably give you kind of a packet to work through those problems. Test 4 on that Friday. And then after test 4, we won't go over any new material. That last week is just review. Review test 1, review test 2, test 3, and test 4. By that time, you will have all your tests back, plus blank tests and answer keys on Blackboard. Last day of class, I'll probably just answer questions, kind of wrap up. I'll probably also try to give you a packet after test 4, maybe even on the day of test 4, of a final exam review. That will cover material from test 1, test 2, test 3, and test 4 for you guys to work on these 2 days to see what you're struggling with. That last Friday is a study day at OTC, so there's no classes on campus. So you can come, go to the tutoring center, and get any questions answered. Your final exam is from 2 to 3:50 in this classroom on Monday. So that kind of wraps up the semester for us. Nothing else after that at all. Nope. Well, unless you have other finals to deal with. You guys don't have a life outside of this, right? No, nothing else on your plate. Just college algebra. No, I feel your pain. I have 5 other classes I teach at different universities too. So, and the last couple of weeks for instructors are the busiest because we have to make the last exam, give the last exam, grade the last exam, give back the last exam, make the final, give the final, and grade the final. So that's a lot of, when you think, usually we just prepare notes for the semester. Grading is very time consuming, and when you have that times 7 classes, it's busy. So I feel your pain. All right, so today we're going to go over the hyperbola. Very similar function, right? You guys see? And we kind of talked about this last time. There's a way to hide this. Because the only thing different than the ellipse is in the ellipse, the formula was plus, right? X squared over a squared plus y squared over b squared equals 1. So the difference here is you add these two, both of them are squared, but one of them is negative. Making one of them negative turns your ellipse into a hyperbola. And a hyperbola is where you have a center, you have vertices, and then your function either opens left or right or up and down. If the negative is in front of the y, it's going to open left or right, right? Or you can think of it, the positive is in front of the x, it's opening towards the x-axis. If the negative is in front of the x, it's going to open up and down, right? So my vertex here, or my center here, my vertexes are up and down. In this example, my center is in the center, my vertexes are left and right. Just like we started in 7-1 with the ellipse, we started with center at 0, 0. And then we talked about a shift. We're going to do the same thing in this section. It turns out you always take the A to be under the positive term. So this A is going to be under the positive term. And the A represents the distance from the center to the vertex. This is A. This distance here is A. Right? So last time we always took A to be the larger one, right? And that would give us the major axis, right? If A was under the x-axis, it means the major axis is the x-axis. If the A was under the y squared, our major axis was the y-axis. Here, the A is always under the positive one. And that represents the distance from the center to the vertex. So if it's under the x, it's going to represent the distance from the center to the vertex right A and left A. If it is under the y, it's going to represent the distance from the center up A units and down A units, right? Do you guys see that? Another thing that's different is the focal point is going to be c squared equals a squared plus b squared. So it doesn't really matter what you call as a or b, right? Because you're going to take a squared plus b squared and then take the square root of that. That is going to be your c squared. But you have to be careful if you're on your x-axis for your focal point or your y-axis for your focal point, right? Both of them are c units, right? This is c units. It's either c units to the right and left or c units up or down. And then the last thing we'll talk about is the asymptotes, which when we look at the center being 0, 0, the asymptotes are really easy to find. They're always A over B or B over A. And for the asymptote, you always take rise over run. Rise over run. So in this case, we go up B units and over A units. Right? So my equation is B over A or minus B over A. Y equals B over A or Y equals minus B over A. You guys see that? And in this case, I go up A units and over B units. So my equation of the asymptotes are A over B or minus A over B. Up A over B. Or in this case, up B over A. Right? So coming in here and drawing this box gives you a really good idea of how to get those asymptotes. Again, our center is at 0, 0. That makes our life really easy on asymptotes. When we shift it, we're going to have to use the point slope form for the equation of the line, plug in the point and the slope, and find the equation. Not too difficult, but it is a couple extra steps. So let's look at graphing hyperbola. It gives you the steps here. Kind of they give you to start with what we're given. The first thing you need to identify that this is a hyperbola because it's negative, right? The negative is in front of the y-axis, so that tells me I open right and left. You guys see that? The x is the positive term. The very first thing you need to identify that this is going to open right and left. Center is 0, 0. What is my A value? A is always the positive one. 2, right? Right. So if I go 1, 2, 1, 2, this point here is my vertex. In this case, it's -2, 0, and 2, 0. Graphing it, pretty basic, right? My focus point. How am I going to find my focus point? I know it's going to be on the x-axis. You guys remember the formula? C squared is a squared plus b squared in this case, because we have a, yeah, so we have, it would be 2 and 3, right? Because if we go back up here and look at the general form, it's squared, right? So a is the square root of what's under x or y, depending on what's the transverse axis. So here the transverse axis is the x-axis. That tells me it's going to open right or left. Do you guys see why I picked that? Because the x is the positive. Then I look under the positive term, and I see the number's 4, so that tells me I go to the right and to the left of that center. So I end up with 4 plus 9, so that's 13. So C is the square root of 13. So my point is minus square root of 13, 0, and plus the square root of 13, 0, right? And a good way to check is this, y is always 0 here. 0, 0, 0, 0. This distance is A, and this distance is C. Right? This distance would represent A. The B comes in handy when I want the equation of the asymptote. So, go ahead. No, go ahead. Okay. And this distance here is C. So B comes in handy to find the equation of the asymptote. So B in this case is 3. 9 square root of 9 is 3. So let's say I'm going up 3 units and I'm going down 3 units. If I was to draw this box here, and if I then draw a line that connects the opposite vertices of the box, that gives me the asymptote. The equation to the asymptote, since I go through this point 0, 0, the equation is rise over run, and I have 2 of them. So the first one I go up 3 and over 2. So this is y equals 3 over 2x. And this one I go up 3 but to the left 2. Oops. That would actually be the negative. Up 3 and to the left 2 would be minus 3 over 2x. And then over here, this is y equals 3 over 2x. This is the positive one. It's the one that I go up 3 and over 2. Question?
How come when you did the foci, this point's 9, or would it be negative?
9?
Yeah, whenever you did 4 plus 9. Just in the when it is given.
This 9?
Yeah.
Because we put the negative in front of the y instead of the 9. So the b, it's always positive. A and b is always positive. And that is part of the assumption here. A is greater than 0 and b is greater than 0. So you always take a and b to be positive values. So do you guys see that? You get the center, you get the focus point. Sorry, you get the center, you get the vertex, you get the focus points, and you get the equation of the asymptotes. Okay, I want you guys to work on the second one. It's very, very similar to the first one, except for the 9 and 4 are switched. So you're still going to open left and right, but instead of opening 3 units, or your vertex being 3 units, your vertex being 2 units from the left and right, it's 3 units from the left and right, and 2 units up and down.
So you want us to draw that box?
You don't have to draw the box, but it is nice to kind of see. I've had students come in here and then draw kind of like dotted lines. That's what your book does. It's going to be much more handy when we shift HK, because our center is not going to be 0, 0 anymore. So we're going to have a point and a slope. So then we have to use point slope form of equation of line and solve for y. But it turns out the slopes are equal, but plus or minus, right? So it's going to be plus or minus m. So you only have to do it once.
So this square
Mhm.
root of 13 thing goes up and down.
In this, on B,
Yeah.
no, it still goes right and left, because the negative is in front of the y, right? So you think of negative as no,
All right.
right? Don't open y direction, open in the x direction. How far do I go from the center? Is going to be the number under either the x or the y. If it's under the x, that tells me that's how far I go on the x-axis. If it's under the y, it's how far I go on the y-axis, and that's to get my box. And that's going to help find the asymptotes. But come on the exam, the very first thing you're going to have to do is identify this as a hyperbola versus an ellipse. Because if you try to do the same thing with the ellipse, you're going to be totally off from the beginning. So that negative is very important. So you guys might think these graphs look very, very similar, right? I have the same vertex, I have the same focus point. The only thing that's different is the slope, the rise over the run, the equations of the asymptote. So if you were to graph this one, it's going to look very, very similar, right? Except that I'm going 3 units to the left and 3 units to the right. My focus point, so this is, sorry, the vertexes are different. This is -3, 0, and 3, 0. My focus points are still square root of 13, 0, and minus square root of 13, 0. But if I think of my equation of my asymptotes here, this would be y equals rise over run. I go up 2 and over 3. So this is 2/3 x, and this would be y equals minus 2/3 x. Right? And looking at these, they don't look any different the way I graphed them. If you graph them on the same coordinate system, you can see that it's just kind of more, the vertex is a little different, but one's a little more squeezed down than the other. how much does it open or close? But they're pretty much the same, right? And intrinsic talk. We'll talk about this at the end. The C value, that's that ratio. See that ratio here. E is C over A, just like we did in the ellipse. How circular is it? Or is it, more smushed like a pancake, or is it more like a circle? And the same thing with the hyperbola. Is it almost more circular, or is it more squished? And that depends on that ratio of C over A, where C can be calculated and A can be calculated. Of course, you might not always be given it in standard form, just like in 7.1. Here we have to convert this to standard form. Standard form is very, very similar to the standard form of the ellipse, where we divide through where it equals 1. So in this case, if I want to put this in standard form, I have y squared over 9 minus x squared over 16, and that equals 1. Your boat tends to use pretty nice numbers that come out. So if I divide through by 144 on all three terms, I get this. So this tells me it's a hyperbola. Which way is it opening? Up and down, right? Opens up and down. And that is because the negative is in front of the x squared. So if I go to graph these, center's at 0, 0, so we're still safe in that manner. The 9 is below the y, so that tells me I go up 3 and down 3 for my vertex. Right? I go up 1, 2, 3 and go down 3. So this is 0, 3 and 0, minus 3. The x is staying the same. The y is changing. So that's my vertex. My focus point, how am I going to find my focus point? Yeah. C squared is a squared plus b squared. In this case, c squared is 9 plus 16, which is 5. So that tells me I go up 5 and down 5. So my x is still 0. So this would be 0, 5, and this would be 0, minus 5. Are these starting to click? Which way you guys go? Pretty much you find out what's A, what's C, and then use your box for B. So B in this case is 4. 4. So if I draw my box in here, go through the opposite vertices, I get the equation of the asymptote. What is the equation of the negative asymptote? Good, minus 3/4 x. And the positive one is just 3/4 x. The graph is not that interesting. What we come through is then identifying all the sides, so, or the points. The center, 0, 0. We're taking that for granted right now. The vertices, in this case, are 0, 3 and 0, minus 3. The focus points, 0, 5 and 0, minus 5. And the equation of the asymptote, y equals 3/4x and y equals minus 3/4x. So this is kind of how you'd answer those questions on a test. I'd probably say center blank, vertices blank blank, focus points blank blank, equation of the asymptotes blank blank, and then you would fill that all in. Graphing is going to be very handy to be able to see that, especially when we shift HK. Your center is not going to be at 0, 0 anymore. It will be at some HK. So it's really helpful to visualize all the x values here are 0. Question.
If the 9 was with the x squared first and the 16 was
Mhm.
with the y squared, then why did they split up to put the 9 on the y instead of the x?
Because I divide by 144. 9 over 144, 16 over 144 is 1/9. 16 times
Okay, got it.
9 is 144. Yeah. Any other questions? Do you guys start to see these? Not too bad. I mean, you guys will work on the second one there. Standard form.
I don't understand.
Okay, so standard form is divide each term by what it equals. So you get 1 on that side. Standard form, you want 1 over here. So this would be y squared over 4 minus x squared over 16 equals 1. Looking at it, which way is it going to open? Up or down, right? So we got our center at 0, 0. Our vertices are going to be 2 units up and 2 units down from our center. So those would be 0, 2, and 0, minus 2. Did you put 2, 0, minus 2, 0? That's probably what most students will miss points on here is they'll get the A right, the B right, the C right, but they'll just they'll switch the order of X and Y. So you should always, drawing a picture is really, really helpful for that because you can say I'm going 2 units up, X stays the same. This point is 0, 2. This point is 0, minus 2. right? Because I'm on my y-axis here. If I'm opening up and down, all my x values are going to stay the same, and my y values are going to be what's changing. The focus points, again, are the same. Calculating z squared of 20, no big deal. Putting the point at 0, comma, square root of 20, and 0, comma, minus square root of 20. Graphically, you can see that. I go up c units and down c units. And then the equation of the asymptote, drawing that box, rise over run, I go up 2 and over 4. Or I go down 2 and over 4. So I have plus or minus a half x. Any questions?
So are the vertices, is that always the y points?
Only if it's opening up and y.
Okay,
if
so
it's
if
opening-
side to side, then the vertices are what's on the x.
The A is the units from the center on the x-axis. So the x is going to change, but the y is not. So in this case, 0, 0, right? If I'm opening left or right, only my x is going to change. All my y values will be 0.
Okay.
If I'm opening up or down, only my y's are going to change, and all my x values will be 0.
Okay.
So as we move forward, we're going to look at hyperbolas that are shifted. If you graph them, you're going to know, okay, all my x values are the same. It might be -3, but they're all -3. So only my y values are going to change. Or if I open left or right, only my y values change. Sorry, if I open left or right, only my x values change, my y values won't change. So I'll know A is only changing the x. Or in this case, A is only changing the y. Everything is pretty straightforward on this except for the asymptotes. The asymptotes get a little more tricky because I have to do point slope form of a line. So the vertex is the point and the slope is rise over run, the same A over B or B over A depending on what I have. So we're going to recall the formula y minus y1 equals the slope. X minus x1 were the vertices, or sorry, the center. The center is x1, y1, and m is the slope. Do you guys remember doing that? No 50 or 040 or 110? So I plug in that point for the center and the slope for the line, and the slope for the line will be plus or minus either A over B or B over A, depending on my box. So let's look at the first example here. First, I'm going to ask, does it open right or left or up and down? Up and down, right? Because the positive is in front of the y term. What is my center? 2 minus 3, right? You look at what makes the x 0, 2. What makes the y 0, minus 3. So some people like to come in here and put it on a coordinate system. I go 2 minus 3. This is my center. That helps them if I'm going up or down when I'm changing, or if I'm going left or right, when am I changing. This is the center. Put it in there because it's 1. What does the 1 tell me? Is A, right? Right? And A is the unit that I go up or down since I'm opening up or down, right? 1 is the number under the y squared term. So that tells me I go A units up and A units down for my vertices. So what are my vertice points? 2 minus 2 and 2 minus 4. And you see the x didn't change here, only the y changed there. So I can draw my hyperbola. All right. I might come in here. My focus point. How do I calculate my focus point. C squared is A squared plus B squared, right? So C squared is 1 plus 9. So C is the square root of 10. This square root of 10 tells me I go up square root of 10 and down square root of 10, right? The x stays the same. So put it here. It would be 2 comma minus 3 plus the square root of 10. And this would be 2 comma minus 3 minus the square root of 10, right? The C value is from your center to your focus point. Because minus 3 is where my y value starts. My center starts at minus 3 for y. And the C would be minus 3 plus the square root of 10 and minus 3 minus the square root of 10.
Yeah, the center is 0, 0.
Plus the square root of 10 minus the square root of 10, right? When that center was 0, 0, I just had to go up square root of 10 and down square root of 10. But here I'm going up square root of 10 from my center. And my center is 2 minus 3. The 2 stays the same. Graphically, we should be able to convince ourselves that that's always x equals 2. It's called the line of symmetry. If I folded this over, it would be symmetric about that line. So that's one thing to keep in mind. Calculating A, B, and C is not hard if you know what you're doing, but graphically keeping them all together, sometimes those points are weird. You got to be a little careful with them. So the hardest thing probably here is to find the equation of the asymptote. I draw that box again, and this is where that box can kind of come in handy, right? So what is my slope? I go up 1 and over 3, right? So my slope is plus or minus 1/3. What is my point? My center, 2 minus 3. So if I use that y minus y1 equals my slope, x minus x1. If I plug in m and plug in x1 and x2, this equals x1 and y1. So I have y minus a minus 3 equals plus or minus 1/3 x minus 2. You'll always have two equations for the asymptote. One of them where the slope is positive and the other one where the slope is negative. So you guys see that I distribute this positive 1/3 here and I distribute the negative 1/3 here. Huh? Oh, thank you. It should have 1/3 x. 1/3 x, 1/3 x, yes. An x and a y for the equation in the line. The point is always going to be the center, and the slope is always going to be plus or minus a over b or b over a. Graphically, you can see that I go up 1 and over 3. Relatively easy to see that. Does anyone have any questions where the point or the slope comes from?
Will we be okay to leave it like that?
You'll need to solve for y. So if we solve for y here, we end up with, here are answers. We're going to end up with y equals 1/3 x minus 11 over 3 and y equals minus 1/3 x minus 7 over 3. I subtract 3 from both sides. I end up with those two equation. So they're not as pretty, but just one extra step is plugging in y minus y1 equals m times x minus x1. x1, y1's your center, and m is your slope. You'll definitely get most of your points if you get here on the exam. It's a little dark. If you make a small, algebra error, I still want you to try to do it, and you'll miss a point or two, but you won't miss very many than if you just don't do anything. So are these aren't bad, are they? Find A, find C, open right or left, up and down, find A, find B, find your center. So you guys should try the next one. Which way is it going to open? Up and down, right? So you can see how I can give you a whole list of these equations and a whole bunch of graphs, and you can match them by just knowing this one has to open up or down. So the only choices are between these two. So what's my center? -1, 4. If I kind of know I'm opening up or down or left or right, I'll kind of put a dotted line there because I know everything's going to happen on that dotted line, except for the equation of the asymptote. Give myself some more space here. What are my vertices going to be? Yeah, -1, -1, because I'm going 5 units up and 5 units down from this point. So 4 minus 5 is -1, and 4 plus 5 is 9. So you won't even necessarily have to draw a box. You do something like this. I know I'm going to go up 5, and then I would go over 2, or to the left 2. C squared is A squared plus B squared. Vertices, from 4, I go up the square root of 29, and I go down the square root of 29. So I get my vertices there. What is my center? minus 1, 4. What is my slope? Plus or minus 5 over 2, right? I go up 5 and over 2, or I go down 5 and over 2. So I plug it in that formula. Y minus y1 equals m x minus x1. Y minus 4 equals plus or minus 5 over 2 times x minus a minus 1. So I could write that as x plus 1. So it's always going to split into 2. Y minus 4 equals 5 over 2x plus 5 over 2. Or y minus 4 equals minus 5 over 2x minus 5 over 2. If I add 4 to both sides, I end up with y equals 5 over 2x, 13 over 2, and y equals minus 5 over 2x plus 3 over 2, 8 minus 5. So that's the equation of the asymptotes. It all comes from the center and the slope. A little bit more work though, because you have to plug it in that equation point slope form. So what do you guys think? Not too bad? Of course, we're going to be given things that aren't in standard form. And just like we did with the ellipse, we're going to have to complete the square. Right? Complete the square, get it in standard form, and then graph it from there. So next time, we're going to look at these two examples. And a lot of times on it, I'll just say, can you put it in standard form? I'll test you separately. If it is in standard form, can you graph it? Can you find the vertex? Can you find the focus points? Can you find the equation of the asymptotes? Can you find the center? But in this example, I'll say, can you get it to standard form? So the first thing you have to do is complete the square, just like we did with the ellipse, except for one of these is going to be negative. So you have to be very careful. For this example, you're going to have to pull out a minus 2 from the y terms. And here you'll have to pull out a minus 7. Both these are going to open left and right. So we'll get there on Wednesday, and I will finish this on Wednesday and hopefully have some time to work on some of the Alex problems.